So I chose my lesson to be on trigonometric substitution because I think it connects to a lot of what my students would learn from Algebra 2, as well as how they connected to finding integrals just of from Calc 1. Okay, so what I would start off with is how do we know which trig substitution to use? So like what I would say is we get these all from like these right triangles, okay? And from there, we're able to decide which trig function we use. So like in this first one, we would have like A is your opposite, and then U is your opposite. So you're using so or sine, okay? So when we have the integral of sine, we're looking for a squared minus u squared. We use then the fact that like u would be a sine of theta. Okay. Then I would just continue on for that. For this next one, this would be your opposite side, and this would be your adjacent. When you use opposite and adjacent, that would be TOA, so that would be tangent. So in other words, we would do a squared plus u squared. When we see that, you use a tangent of theta to be u. And then finally for secant, secant is where you have just the opposite of tangent. So that would be like if you had this is your hypotenuse, and then this is your adjacent or opposite side, and this is your adjacent, okay, you would use the fact that it would be u squared minus a squared, so the opposite of tangent from above, so we would use secant. Okay, so I would just summarize it in this chart, and I would say you need to memorize this when you're doing trig substitution. Okay, and then just some helpful hints with that as well. Okay, so then I would start with an example that's kind of already guided. So it says in example 1, using trig substitution, derive the formula. So in other words, prove that it equals this. Okay, so what I would start off with, it says since this integral involves a squared plus x squared, we're going to use it in the form a tangent of theta for x. Okay, so I'm giving them the x for this one. What I would say from there is you have to find dx. So what that means is you have to take the derivative of this. So it would be a secant squared of theta, because the derivative of tangent is secant. Okay. So then when I'm plugging this in, okay, what I would do is I would basically plug in what I have for each part, okay? So what I would start off with is I would start off with, this is going to be dx on top. Dx is equal to a secant squared of theta. So it'd be the integral a secant squared of theta over, you don't know what a squared is, so I leave it, but then you have x squared. Well, x is just a tangent of theta, so it'd be you would square both a and tangent, so it'd be tangent squared of theta. Okay. And then this would of course be d theta because we're integrating with respect to that. Okay. So then from there what I would do is just simplify. Okay, so how would I do that? Well, first off, I would just have a secant of theta, and then I would factor out an a squared so that you're left over with 1 plus tangent squared of theta. That'll help me out because that is an identity, okay? It's just this right here is secant. So what I would do from there is I would have a secant squared of theta over a squared times secant squared of theta. And look at what happens. This is the nice part. The secant should cancel off, and then one of the a's cancels here with the 1a on top. Okay, so you're left with, in other words, 1 over a d theta. Okay, and then remembering that a is just a number, what I'm going to do is to integrate it, I would just add a theta. So it'd be 1 over a of theta. But then I need to replace theta with what I originally started with, x. So I would say, okay, now you're going to go back up here, and you're going to say, how do I solve for a and that? Well, that's just by taking the, taking the inverse of tangent. So in other words, here's what it would be. You would first divide by a, so it would be x over a equals tangent of theta. The opposite of tangent is the inverse, so it would be tan inverse of x over a equals theta. and I would replace it with that theta I see there. So my final answer would be this. It'd be 1 over a times tangent inverse of x over a, and then plus c. And then if you look above, that's what I was trying to find. Okay. So I would just talk about that first, okay? Then I would go on to a couple other problems where it specifically said, like, evaluate the following function. So what I would point out is this. I would point out that not every single one you have to use trig substitution. Like for this one, you could do like integration by parts, or I'm sorry, integration by like decomposition. Okay. So you would factor it. Okay. But then in that next one, I would do this problem with my trig functions, okay? So now noticing I'm adding this part, the fact that you have an x squared up front, and I'm adding 2 extra bounds. So when I do this, I would start off with, okay, it's x squared minus the number. That means it's x squared minus your a squared, and 1 is just 1 squared. So what I would do is I would look above. I would see that that trig substitution would be the first one where it's talking about u squared minus a squared is going to be secant. So in other words, your a value is just 1. Okay. So in other words, x would be a is just 1. It would just be secant of theta. And then from there you need to find dx, which would be, that would be secant tangent. Okay. And then replacing what I have. So from there, I would integrate it. Okay, I'm just going to put it as 1 over, I'm going to put the dx next to it. Okay, but first off, this x squared right here, that would be secant squared, and then secant squared of theta. And then from there, this one would be secant squared of theta minus 1 times your dx, secant squared of theta, times tangent squared of theta, d theta. And then you would just cancel out things based on that. So from there, I would have, this is just 1 over, this would be secant squared of theta. This right here is tangent squared of theta from the identity. And then take the square root, you would just have times tan of theta, okay, times secant, and then tangent. Okay. And then I would see what things cancel. So first off, the tangents cancel. One of the secants cancels here with that. And so you're left over with 1 over secant of theta, d theta. Secant is the opposite of cosine. So this is really just cosine of theta, d theta. Okay. And then the antiderivative of cosine would be sine of theta. Okay. But then remember, I have to replace my theta with my x value. So in other words, what I'm doing is I have to figure out how to solve for theta up here. So in other words, I would do the opposite of what's given to me. I would do theta is equal to the inverse of secant of x. And I would replace that. Okay. So it would be sine of theta, or sine of secant inverse of theta. And this problem also hits on the idea of like inverses and how to do a complex inverse. And then you're just evaluating from, -2 to -√2, okay? And I would just say integrate from there, okay? But the overall idea is that you just have to follow the logical steps. You have to match somehow your trig identities to what's occurring in the problem. And then also finally, you should be looking for like if things cancel out, if things kind of reduce as a fraction. And so I think this kind of integrates all those steps into like one perfect problem. That's kind of why I liked it and why I picked the lesson. But overall, that's kind of what I would hit on. I would tell the students further if they wanted to look at the examples that are already written out. You can always use integration by use substitution, integration by decomposition. This is not the only option, but it is a possible option. But yeah, that's where I would start it. But yeah, thank you.